and the division property of equality. Remember that when we're talking about those problems, when we look at them, we're still multiplying and dividing on the same side. Or rather, whatever you do to the left, you have to do to the right so that things stay balanced. You don't want the left side to be heavier or the right side to be heavier. So whatever you do on the left, you still have to do on the right. But now instead of making zeros like we did with addition and subtraction, now we're looking for ones, right? Because that's the multiplicative identity. So we use that additive identity of 0, and now we're using the multiplicative identity. I think I might have misspoke when I said that last. So we're looking now for that multiplicative identity, and we're either going to multiply or divide to get it. So that this problem says 8x equals 56. Our variable is not alone. It's being multiplied by 8. You have the first two answers there. Fill them in. So if I want to go ahead and undo a multiplication, the inverse operation, or what do I have to do to have that be a 1x? I would need to divide by 8. Because 8 over 8 is a 1, we get that 1x, that multiplicative identity. That's what I want to know. How much is 1x is equal to 56 divided by 8 is 7. So we used our division property of equality. Right? We used our division, we can divide it out. What can we do? We can divide by the division property. And that's what allowed us to say that x was equal to 7. We always go back and double check. When you pick up that x value and replace it in the original equation, that would be 8 times 7. And 8 times 7, yep, it's 56. So we checked it and it works. Three x, 4x. Ooh, here's one that we haven't seen yet. A divided by 12, or a 12ths, is equal to 5. Let's do this one together, and then I'll let you loose on those other three. So we'll draw on our balance line. This problem has a divided by 12. So we need to use that multiplicative property. We need to multiply by 12 over 1. Remember that that's really a 1a, right? So we're going to multiply by 12 over 1 because 12 over 12 gives me a 1. So I'm now left on the left-hand side with an a value. Whatever I did on the left, I also have to do on the right. And it's a 12 over 1, which is really just a 12. 5 times 12 is 60. And then we do our check step. If I do 60 divided by 12, right? If I do 60 and I divide by 12, do I get 5? Yes. So that was my using my division property, or rather my multiplication property of equality, multiplying on both sides, as long as I do it on the left and on the right. You got 3 practice problems. Give them a try. So here are all 4 answers all together. And again, make sure that you're keeping things balanced. Whatever you do to the left, you have to do to the right. Whatever I did on the right had to happen on the left. And whatever happened again on the right had to happen on the left. I think we have one more page for this set of notes. Yep. And these are these ones that are a little bit different. 3/5 times x is equal to 6. Look at the side the variable's on. Is the variable alone? No, it's not in this case. What's in the way? Well, that's kind of the answer to the y part. It's being multiplied by 3/5. It's being multiplied It's being multiplied by 3/5. What can we do to cancel it out of the left side? So we would normally say that we would undo multiplication with division, right? We would divide, but we would never divide by a fraction. We just had that in chapter 2. We're never going to divide by a fraction. We can always multiply by the reciprocal. Never divide by a fraction. Always multiply by the reciprocal. We're allowed to do this for 2 reasons. The most obvious is whatever I do on the left, I have to be able to do on the right. It doesn't matter what I do, as long as I stay balanced. But dividing by a fraction, well, dividing by a fraction is ugly. I mean, here, let's just look at it for a second. If I take this problem and I divide it by 3/5, that just looks ugly. And I don't want you using your calculator in places where you don't really need it. Your calculator is going to become a hindrance to you if you have your fraction rules down pat. I don't want you using your calculator on this. I really, really, really want you using your brain. So that instead of dividing by that fraction, we're going to take and we're going to multiply by its reciprocal. So that's 5/3. Remember, whatever I do on the left of that balance line, I also have to do on the right. So the reciprocal, 5/3, and I'm multiplying by it. I'm doing that because 5/5 becomes 1. 3/3 becomes 1. So I now have a 1x equal to, take your whole number and make it into a fraction version, so it's over 1. With multiplication, we can just start simplifying. 6/3 is the same as 2, so we'll change that into 2/1, because the 6 was in the numerator and the 3 is in the denominator. And now I can just multiply straight across. 2 times 5 is 10, and 1 times 1 is 1. And anytime I have something like 10/1, I can always finish my answer and just write the whole number of 10. Use your calculator to check if you want, but make sure you do. If I take 3/5 times 10, remember you could treat that as 10/1. 10/5 becomes a 2/1. 3 times 2 is 6, and 1 times 1 is 1, so we get just 6. And it's a true statement, so we know it's the solution. These are probably the problems students have the most difficulty with. So let's agree that our fraction rule is, if a fraction is in front of our variable, we can cancel it out by multiplying by the reciprocal. Cancel it out by multiplying by the reciprocal. So that there are 4 more problems here. Would you please give them a try? Practice them. See how you do. When you get to the 3rd one, I'm going to go ahead and record all the directions for that. So give it your best effort, and then we'll check it out together. So when I'm looking at this 3rd problem, we went ahead and we multiplied by the reciprocal because we want to get the x, which was multiplied by 10/3. We now have to multiply both the left and the right by 3/10. So that's where that 3/10 came from. I did it because 10/10 gives me a 1, 3/3 gives me a 1. So I now have my 1x on the left. On the right, you can use any of your multiplication rules. I went ahead and started simplifying because I saw that 20/10 became 2/1, and I saw that 3/6 became 1/2, so 1/2. I went ahead and I multiplied across, and I ended up with 2/2, which means I didn't get all my simplifying that I could have possibly have done. So I went ahead and simplified one more time, so that 2/2 becomes 1, and I went ahead and made my 1x become invisible. You can, or you don't have to. I will never mark a 1x wrong. I will, however, mark a negative x wrong. So let's work all the way through this fourth problem together. So we have negative 1/2 y equal to negative 14. My y is not alone. It's being multiplied by negative 1/2. So to make that go away, I need to multiply by the reciprocal, which is negative 2/1. Remember that reciprocal, that multiplicative inverse, is what causes my answer to become a positive 1. So 2/2, 1/1, and a double negative gave me 1y. So now that my left side is all set, I need to work on my right side. Whatever I did to the left, which was to multiply by negative 2, I also need to do on the right. Multiply by negative 2. Notice that I'm going to lose my fraction piece because I don't really need 2/1. I'm multiplying times negative 14. A negative times a negative is a positive. 14 times 2 is 28. And that makes us done with section 3.1.